Yeah, so we covered the model view controller pattern, and we will be doing a class diagram over this. But we have one more thing that we should actually add to our little game, I think. And that is another type of view. Since this is kind of like one of the major points of the model view controller pattern, maybe we should add another view to just try it out and see what happens. So, to make things a little bit simple, we won't be changing to another API or something like that. We will just be doing a translation here, I think. We'll call it Swedish. So instead of printing stuff in English, we will be printing stuff in Swedish. Something like that. I think you will get really messy, strange characters for our special. Yeah, okay. Yeah, thank you. And that is also now something that maybe this should be a static variable or global variable in this class or something like that, so that you don't need to change it in two places. But because as you saw, I forgot it, and I would probably run it, and I would wonder what the is happening. So let's just try and compile that. It seems to compile. No, I'm not using it. So we will use it instead. So, and here we will create a new something like that, I think. And in the controller, we also need to change. This should be a Swedish view, and this should be a Swedish view. Yeah, we at least get some Swedish language here. Oh, hope I get 3. Yeah. So, all right, and I could press the S to quit. So we have some change the interface, and we have some changed input. Not a huge amount of change maybe, but at least to demonstrate. So let's take a look at these two classes now. Do you see anything when I flip between them? We have the original console, and we have the Swedish. They share a lot of code. So not much is actually changing when I flip here. Sometimes it's maybe not that obvious, but in this case it is. So this function is the exact same function. I think this function is also the exact same function. What should we do now? We have duplicate code in 2 different classes. Inheritance could be a solution. Absolutely.
But isn't that dangerous though? If you want to have different views, they might, at some point, the inheritance might not work anymore.
Yeah, absolutely. The
Separate your views.
Yeah, inheritance is comes with the backside that you sometimes does not always think about all the cases that you might encounter. I think though that in this case it's pretty good to use it because we have this duplicate code, and this, I think, it's a driver for using inheritance. So, and it will also give us an example of inheritance. So let's just do an English type. Oh, oops. Oh, copied the class file. And we will use the original console type to encapsulate the common stuff. And this was the common stuff. The wants to quit was a little bit unique. We had different characters. This is also unique, and present instruction is unique, and present result is in some way unique. But this present die with value is also something that is duplicate. Yeah. In this case, you could also, of course, make some kind of data-driven system instead, but that would not really prove my point in that way. And actually, user interfaces are quite hard to data drive in most instances, because translations sometimes also give a lot of layout changes in user interface. Translating to German, for example, is a nightmare because it's kind of like 1.5 times longer sentences than in English. And this will often really mess up your user interface. Yeah. So we will just use these as abstract functions here instead, abstract operations, because this is kind of like the stuff that every type of console view needs to implement this in their own way. We can take the English view, extends console, and we can remove that, and we can remove that. So we keep the code that is unique for each type. It's maybe not super duper unique, but I think every line at least changes. Maybe the if statements here could be further divided, but we should not overdo it. And we can keep the common stuff here, and we can make abstract functions, operations out of the other operations. And this means that, okay, I would like to do a console German view. I extend the console, and then I compile, and I will get a list of stuff that I need to implement, because it won't let me compile without implementing once to quit, present welcome message, present instructions, and present result. And that is a great thing, because that means you can't really ship your application when it's obviously wrong. You need to make those implementations. yeah, we need to make the class abstract also. So then, let's compile. And hope for the best. This is maybe a little bit too good to be true, so yeah. And this also has the advantage now that the controller does not need to be dependent on the exact view we have here. This can only needs to be dependent on that it is a console view. But is it a Swedish console view or English console view? Well, the controller doesn't matter if the interface is in Swedish or in English. And this is a great advantage, of course, because as you saw when I switched to Swedish, I had to change in a lot of places. I don't need to do that anymore. I don't need to change the controller at all when I add another type of view. So we will compile and hope for the best. Yeah. So now actually I just need to change, also do that, change stuff here. And it should be back to English. And you could of course, okay, I could read from the arguments to the application what language I should use and instantiate the different view objects in that way, or read from a file or something else, or let the user decide. When he starts the game, the first controller should decide on the language and then hand over to the play game controller. And we got a nice little implementation of an abstract class that we kind of like saw could exist because we had duplicate code in two different classes, and the type refactoring there is to make an abstract class or something like that you inherit the functionality from, or the location of the computer. And you can also see here that one of the goals of designing software is to make it easier to make changes, make it less error prone. I don't want to, if we would like to add a new view, I don't want to change stuff all over the application. If we would like to add a new view, I don't want to risk missing something. So we can use an abstract base class and it will tell you, you need to implement this. If you don't, it won't compile. So that is also one of the goals of designing, I think. Make it easier to implement. Restrict the choices that the programmer has. You do stuff this way. You only have these objects at your disposal. You need to use them. You get compiler errors when you do stuff in the wrong way. You get compiler errors to indicate what you need to do in your application. Yeah, you could, of course, add some kind of selection, add maybe another controller to select the language. I won't be doing it today, but it could be a good exercise for those who would like to do that. And as we discussed also here at campus during the break, before we had the observer pattern, kind of like both the controller and the take a look at the old code maybe. If we go back to look at the controller in the old code, it was kind of dependent on the fact that the game had two dices. Because we used this, okay, get the first die value and get the second die value. In some way it was dependent on, okay, there is two dices in the game. And also the view was dependent on this because it took two arguments to the present result. This means that if we would like to add a 5 or 6 or 7 dices in the game, this would need changes in the user interface. And in this new design, both the controller and the viewer are totally oblivious about the presence of a number of dices. So we could remove a die from the game, or we could add dices, and it will work anyway. Possibly you won't always get that bonus when doing the implementation of the observer pattern, but in this case we did, and it also points to the power of the observer pattern. And you could also see that we could remove those two methods here that kind of like revealed to the outside how many dices there were in the game. So, okay, questions on the implementation. We will be doing a class diagram for this. So we can see, yeah, in a web application, web applications work in a little bit different way, but I think the principles can be used anyway. Yeah, and the statelessness of the web is kind of like what makes things a little bit wonky. And often in web applications, you don't use the observer interface at all, because you kind of like reload the view every time and poll the model for any changes in data. So in the case of the web, the views kind of like ask for data, or the controller asks for data every time you reload a page, more or less. And if you need to, if you need to make it look like as if you get results immediately, you probably you add some kind of JavaScript in the client, and it polls a controller for data that you need. Yeah, Ajax from the client asking for new data all the time. So, all right, a class diagram. Have the die still. The dice game. That was nice. We have our two die. D1. D2. Die. We have our interface. And actually, the dice game contains a lot of objects of that type. A star. And it was called subscribers, if I'm not mistaken. I think this is about it on the model side. Nothing really revolutionary there, I think. The new interface is just noted like that in UML. At least in one of the ways you can do it. I prefer that way. Yeah, the star is 0 or more instances. Because the dice game would work perfectly fine without any listeners. They don't need to register if they don't want to. The controller, I could change color now maybe to green. Play game, I think it was called. We have a few more changes here, I think. First of all, the play game implements the die-rolled listener interface. So we have actually a new kind of relationship here. It also is dependent still on the DiceGame. Had an operation that took a DiceGame instance and used it to play the game. And thirdly, we have the view, and here we had the console, and that's an abstract type now. Do you remember how you did the notation of an abstract type? We mentioned it once. You kind of like write it in italics. So I don't think that's a very good notation for when you scribble down stuff, because it's kind of like hard to know if it's italic or if it's just messy. And we had the Swedish, I won't be writing the whole name. I don't, that. Yeah, but it's kind of like removes half the diagram sometimes, so I don't dare press it. And here we have the inheritance, or generalization, specialization. And if you remember also, we had a something like that, I think, is the class diagram for this application right now. And actually, we have all the 4 kinds of relationships that you need to know for this course in this diagram. We have the association. We have the dependency. We have generalization. And we have realization. That is what you need to know. And you don't want to confuse them also, because especially the realization and the dependency can be confused if you miss the whole arrowhead there. And it will mean quite a different thing. And this,
What's the difference?
the difference is here you need to implement this interface. And in this case, okay, I have an operation or something that takes an object of that type. This is a dependency.
What's the difference between the dotted line, the DiceGame, from a solid line down to the view?
Yeah, this means that there is an association, and you need a member variable to keep that association in some way. So we had a member variable in play game of the type console named mview. And the same thing here in DiceGame, we had a list of subscribers, list of objects implementing the die-rolled listener interface. We had many, and we called that one mSubscribers. So when you have a member variable that contains something of another type, you have an association. And these multi-dependencies or multi-associations here where you can contain many, you often use kind of standard classes for that, arrays or linked lists and stuff like that. So to be really, really technical, the DiceGame should go to a linked list class really, and that in turn contains the objects. But I think it does not really add any value to the design, to the class diagram. So this is the meaning of the star kind of like tells us, okay, we need some way to keep many instances of this. In the implementation, we selected to use a linked list. Yes?
Is generalization when they inherit also?
Yeah.
That is generalization.
Yeah. In UML, it's called generalization. In programming languages, you use inheritance to do that. So the console is a more general concept than the Swedish console. And also, you don't want to mess up the switch between association or generalization. Those are kind of like the two errors you can make. You mess up the realization of the dependency, or you mess up generalization with association.
And realization, is that when you implement
An interface. Yeah, that is realization. You realize the interface. You implement the interface. Yeah. I will just write down the arrows and we can take a look at them separately. So we first have maybe association. Something to actually remember with association is this is important when designing. The role. And the role has a name. The role has a multiplicity. And the role has navigability. So actually both ends of these associations have roles. But when designing, we focus on the end where that the association points to, so to speak. And you have the dependency. In what ways can you get a dependency? You have a function, for example, that takes an argument of an object. We use that object in this function, but we don't store it in a member variable. Because if you have an association, you don't put out the additional dependencies, unless it's maybe something really, really special. So, getting arguments to your operation is one way to get dependencies. We can send in objects via arguments. Is there other ways that we can get a hold of objects that we need to use in some way? What? Yeah, how do you mean? Yeah, yeah. And you get the object as a return type. So you can get objects. You can ask one object, can I get this other object from you? Yes, you can. And you get it back, and you can get it as a return type from a function call. So that is a second way. You can have two-way dependencies, but generally it's a big no-no. So, and that goes for associations and kind of like all these arrows. When you get circular stuff, it often gets very messy. So I don't think you maybe even can have double inheritance, because that would kind of like not make sense. So okay, we have arguments to operations. We have return types. What else can we do? It's almost like a special case of the get as a return type. You can create an object. You can call the constructor. You can create it. If you need an object, well, you don't have it, you don't get it as a return type. Oh, maybe I need to create it. You create it and you use it and you throw it away. So you can create objects. And the fourth way, fourth way is to use global variables. Or maybe something like static types, static functions, static function calls. And as you know, don't do that. All right, continue, and we have we have generalization and realization also. So use inheritance if you have some kind of implementation that you need to reuse, or you make an interface that cannot contain an implementation that you kind of like would like to use more as a contract. Yeah, and as you see, as has been noted, you can make an interface like this. I will just call it I because I don't like to type so much right now. And you can write it on top. And this is called a stereotype. And it's one of the mechanisms in UML to add stuff to existing stuff. So we have a class, but we would like to change that class to an interface, add more semantics to it, and we can use that using stereotypes. And those bigger than or less than are actually some kind of special characters. But in real life, it's always bigger, bigger, less, less. Some weird ASCII code, actually. And if we have some class to implement, use this. And to make things a little bit more complicated, stereotypes can also change the look of the diagram. So this could also look like this. You have the implementation, and you have the interface as a circle instead, and you have the implementation, the realization of the interface, as a straight line. These two are equivalent. And this is called the lollipop notation. So if you see this, it means that. No, you don't have to flip it, but it will become so weird in the layout because the line would go through the eye, so it would just mess up my drawing. You don't need to flip it. I think time is running out slowly. What should you use? Yeah, I personally do not use the lollipop notation. It's not that common in class diagrams, really. You see it more in component diagrams that we won't be talking about, where you have components that expose different interfaces. In some tools, you can change how you would like this to look. So there you could use some setting or property and say, okay, you should use the stereotype name, or you should use the special look. Other questions? Yeah, okay. Anton had some kind of question. Is it about the two-way dependencies? Or are realization always implementations? The realization concept in UML is kind of big. It can be used for quite a lot of things. When we talk about design, though, they become implementation in the code. So as maybe you see, the kind of like notation and the diagramming, it's quite mechanical. It's actually no problem making diagrams. If you know what the arrows mean and have some kind of understanding of the notation in the code, you can just imagine it is as code. Or you type the code and you do the diagram after you have the code. Or you do a little bit of both. So I won't be hassling you so much about looking at specific aspects of the notation. You can look that up in the book. There's the pages, first and last pages of the cover are really good in that way. Rather, the hard parts about designing software is finding the right abstractions, finding the right, where should we put effort into reuse, where should we put effort into change, what parts can we kind of like sacrifice. Yeah, the author in the book has the point of view that the sequence diagram is better when designing. And we will be following the book by the book way, so to speak. That is not the way that I learned design, and not the way that I immediately think about design. I think about classes and class diagrams and relation between classes. And then I use sequence diagrams or stuff like that to kind of like test drive my class diagrams and see, okay, is something missing, is something too much. I agree with the author's point that thinking about class diagrams first you have a tendency to over-engineer. You have a tendency to add a lot of stuff that you don't really need, or put effort in a lot of fancy features that you don't really need to have. How you choose to do it, it's up to you. If you do code first, if you do sequence diagrams first, if you do class diagrams first. I don't think you should spend too much time on anything for too long before switching to another point. So do a little bit of coding, make a class diagram, make a sequence diagram, code some more, update, change, use these tools as fluent as possible. So don't spend days designing, don't spend days coding. Questions? We did not really get to the architectural parts today, so we will continue that tomorrow and cover the last parts there. But I think we got a lot of design work done today, and that is always good. I'm done. Are you done? Yeah. See you tomorrow then.